Guys, in this video we will find the eigenvalue and eigenvectors of a 3 cross 3 matrix. So here we consider one 3 cross 3 matrix, that is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. So now for finding the eigenvalue of a 3 cross 3 matrix, we have to first consider the characteristics matrix, that is A minus lambda I. So A minus lambda I means here we can write that is the matrix A and minus lambda into identity matrix of order 3. And after A minus lambda I, we get the characteristic matrix is like 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda. And now the characteristics equation is mod of A minus lambda I is equal to 0. The characteristics equation is mod of that is the date of A minus lambda is equal to 0. So if we now expand along the first row, we will get this line, that is 6 minus lambda into 3 minus lambda whole square minus 1 plus 2 into minus 2 into 3 minus lambda plus 2 plus 2 into minus 2 into 2 minus 2 into 3 minus lambda. And from here, if we simplify, we get 6 minus lambda into lambda minus 3 whole square minus 1 plus 4 into lambda minus 2 plus 4 into lambda minus 2 is equal to 0. And now here we just simplify it, that is, see here that first we get 6 minus lambda into lambda minus 3 whole square minus 1. In the next step, we will use here the formula of a square minus b square. So if we write here, that is, we get 6 minus lambda into lambda minus 3 plus 1 into lambda minus 3 minus 1 plus 8 into lambda minus 2 is equal to 0. And after simplification, we get 6 minus lambda into lambda minus 2 into lambda minus 4 plus 8 into lambda minus 2. And here we take common lambda minus 2, and then if we take common minus of take common minus from here, so we can write that lambda minus 4 into lambda minus 6 minus 8, and if we simplify now, we get lambda minus 2 into lambda square minus 10 lambda plus 16 is equal to 0. Then by after simplification, by the middle term factor, we will get lambda minus 2 into lambda minus 8 into lambda minus 2 is equal to 0. So from here we get the lambda minus 2 whole square into lambda minus 8 is equal to 0, and the eigenvalues are 2, 2, 8, and here one eigenvalue is repeated, that is 2. So now we have to find the eigenvector with using the relation Ax is equal to lambda x. So now here we take first the lambda is equal to 2, and we take the corresponding eigenvector is capital X is equal to x1, y1, z1. And from this relation Ax is equal to lambda x, we can write A minus lambda I of x is equal to 0. And as we know that A minus lambda I, already we know what is A minus lambda I, so put the value, write the matrix of A minus lambda I, and then we put the value of lambda here, that is the lambda is equal to 2. And after putting the value of lambda is equal to 2, we get 4 minus 2 2 minus 2 1 minus 1 2 minus 1 1, x1 y1 z1 is equal to 0 0 0. So from here, now we can write from here that if we multiply the first row and second row by minus 1, we get 2 minus 1 1 2 minus 1 1 2 minus 1 1 x1 y1 z1 0 0 0. And see here the system is equivalent to only one equation, that is 2x1 minus y1 plus z1 is equal to 0. And see here the number of equation is 1 and the number of variable is 3. So here there are two variables. We can choose that either x1 y1 or y1 z1 or x1 z1 as free variable. So here we choose the x1 and z1 as a free variable. So we choose, that means we can choose the value of x1 and z1 arbitrarily. So arbitrarily we choose the x1 is c and z1 is d. So from this relation we can find the value of y1 in terms of c and d. That is y1 is equal to 2c1 plus d. So the eigenvector we can write that c1, that is the form is x1 y1 z1, x1 y1 z1. So we put the values of x1 y1 z1 column wise, that is c1 2c1 plus d and d. And from here we can write that is c1 1 2 0 plus d 0 of 1 1. Actually from here we can write that the c1 for your convenience, c1 plus 0 into d, 2c1 plus d, and d plus 0 into c. I think now it is clear to you that how can we write in this format. So now we will find the eigenvector for the eigenvalue lambda is equal to 8. So here we take the eigenvector x is equal to x2 y2 z2, the eigenvalue for the corresponding eigenvalue lambda is equal to 8. Similarly here we have to find, we have to use the relation x is equal to lambda x, and here we can write a minus eta is equal to x. that is, and now if we put that is, if we simplify, we get 6 minus 8 minus 2 2 minus 2 3 minus 8 minus 1 2 minus 1 3 minus 8 x2 y2 z2 is equal to 0. And now if we simplify, we get this matrix, and from here we can write that 2x2 plus 2y2 minus 2z2 is equal to 0, 2x2 plus 5y2 plus z2 is equal to 0, and 2x2 minus y2 minus 5z2 is equal to 0. See here the three equations are different. For this case, we can, for finding the eigenvector, if the if we get the relation like there are three different equations, so we just take any of two. That is, we just take here the first two equation, and then if we find the value of x2 and y2 by using the cross multiplication method, that is, the x2 is equal to x2 by 1 plus 5 is equal to y2 by minus 3, and z2 by 3 is equal to c dash. Whereas we can say that there is infinite solution. So here we can get that x1 is equal to 2c1, y2 is equal to minus 3 dash, and z1 is equal to c dash. And now we can say that the eigenvectors are like c dash 2 minus 1 1. And here we take, since we choose the c dash is arbitrarily, so the eigenvectors are c dash 2 minus 1 1. So I hope you understand that how to find the eigenvectors of a 3 cross 3 matrix. So thank you.